It's 11:30, so talk will start. Welcome, everyone. Thank you for joining us today for the TMLS Machine Learning in Finance Micro Summit. Before I introduce our next speaker, I just want to remind everyone to update your profile with your job title or company. This makes it easier to connect with other people who are also attending the summit and helps you get the most out of the online experience. Now, without further ado, I'd like to introduce our next speaker, Susan Su Chang. Susan is a principal data scientist at Clearbanc, where she builds and ships machine learning at scale. Susan is also an indie game developer and has created games which have been showcased in major gaming news sites such as PC Gamer. She shares her wealth of knowledge through speaking at machine learning as well as game development conferences, and she also writes career guides, which can be found at susansu.com. She will be giving us a talk on machine learning deployment and product integration. Please give a warm welcome in chat to Susan.
All right, thanks a lot, Peter. Hopefully everyone can hear me and see the slides as well. So it's really good to see you all. It feels like it's been forever since I last spoke at TMLS, which was 2 years ago in Toronto, and it was really busy. Lots of food too. And actually today at the conference, I saw a lot of faces that I recognize, and I just want to say, a lot of you, your hair has gotten longer, just like mine. And so I'm excited to be here today. I'll be talking about machine learning deployment, especially when ML is part of a core product. So first of all, a bit about myself. A lot of it is what Peter mentioned. First of all, I am a principal data scientist at Clearbanc, and on the side, I'm the founder of the video game studio, Quill Game Studios. On behalf of the game studio, I've spoken at several PyCons, which is the largest Python conference around the world. And some of you might know Aggregate Intellect, which was a long time ago called TDLS, Toronto Deep Learning Series. So it's a machine learning community and platform with 13,000 plus YouTube subscribers, and I host the reinforcement learning talks there. And I also write data science and career guides on my site, susanshu.com. Now I'll introduce Clearbanc, where I currently work as a principal data scientist. So Clearbanc is an investor that focuses on e-commerce businesses. We provide a large variety of products to support founders, like the recent Clear Angel, which is a platform that helps founders track revenue goals and connects them with partners, and Valuation, which estimates a business's valuation with a simple online tool. But many of our products are powered by our machine learning infrastructure, which I will be covering in this talk. So of course, machine learning isn't just limited to tech companies or companies focused on ML and AI. I do want to mention some examples where machine learning techniques have been used frequently, as long as the companies have data. For example, in industries like retail or telecom, churn models are used to predict what customers might leave, which then helps the business proactively reach out and prevent customer churn, for example. In banking and insurance, ML for fraud detection is commonly used. And the previously mentioned examples are in relatively traditional industries, but regardless, machine learning helps provide instant improvements for their core customers. And these examples are more likely than not to be batch processes, just generalizing here. So they could be running nightly or weekly, and not necessarily running on demand. But of course, in both tech-focused and non-tech-focused industries, there's been a massive growth of machine learning-powered software products that do require serving on demand and require fast response times. So for example, these could include recommender systems on YouTube, Spotify, and other types of websites, right? Because a user is on it, the model inference has to happen as the user is clicking through and experiencing the site. So now just to bring it back to Clearbanc, our machine learning inference is kicked off when a founder signs up to apply for funding from us with a simple sign-up form, which is on the picture, and it's commonly mentioned in the media as a 20-minute term sheet. So anyone who goes through this website flow, just like this is public will be asked to hook up their accounts information like the Shopify store or PayPal, which is part of the data that is required for the machine learning powered process here for funding adjudication. So that means decision making for funding. So to create our advantage to provide fast and flexible funding to founders, a little bit of a tongue twister here, and we do it non-dilutively, so which means we don't take their equity. The machine learning powered decisions are a core functionality in the broader end-to-end adjudication process. So with that context, we'll talk about some common challenges of machine learning in production, and then we'll talk specifically about helping machine learning be more portable and nimble, and how that helps the data science team build better machine learning pieces in overall products. So let's talk about types of production. In the example of a churn model that I mentioned earlier, which is predicting customers that might leave a company or ditch the product or something, a data scientist could build a model and then it's passed on to a machine learning engineer with the understanding that the machine learning engineer would be responsible for helping the model automatically run weekly, perhaps. Or the churn model's outputs could feed into some sort of dashboard that's used by other departments in the business. But the integration isn't necessarily done by the data scientists themselves. And actually in, I guess, like the larger the company or the larger the team, the less likely that this end-to-end process is done by the data scientists themselves. And for machine learning that requires much faster response time than batch, such as on-demand runs or on-demand inference, there are many cases where the data scientist will build the model and pack that up, and then it's fed somewhere downstream into some sort of front end or some sort of other logic piece. So realistically, whether the machine learning is doing what it's intended to do, it does rely on the infrastructure that goes around this DevOps cycle in the image, such as release, deployment, and so on, which is on the bottom right side, but then it goes around and around from coding, building, testing, releasing, deploying, and so on. The thing is, oftentimes data scientists might not have visibility into what happens after they pass along their machine learning model. A silo is created around when the data science team trains and builds models, which loosely fits into the two code and build portion in this DevOps cycle, which is in the box there loosely. They might have no visibility into how the website front end is maintained or the back end, or understand like that their code could have bottlenecks because of the way they have built something in their machine learning model that they threw over the wall to the next team. And in addition, the communication friction is increased with each step where the work is being passed along to someone else. So now we have this problem which you might relate to, because models can be difficult to put into production in the first place. How often do you train models that don't even make it out of your local or development environment and they never see the light of day, right? They could be in your untitled1.ipy notebook. And this is a screenshot I took from my actual computer for some other talk a while ago. And they're very small in size. So I believe I didn't do much with them, but everyone in data science have some of these. So second of all, you might write some snippet of data pre-processing code and you might put it in some helpers file, but then because the process of going to production is fragmented, someone ends up rewriting it. Or you yourself end up rewriting something similar for another project instead of having things be reusable. And then third, because machine learning product development can be very fast-paced with all of this kind of hot potatoing, oh, my model, my pre-processing goes to someone else, then I don't own it. No one knows who owns the model or the pre-processing or anything. This leads to what I mentioned before with the Jupyter notebooks, for example, never seeing the light of day or wasting time redoing things, like a machine learning engineer not being able to run the data science code properly, or the data scientist not being able to replicate some sort of environment passed from another data scientist. And because of this lack of end-to-end visibility in the production process, there's just a lot of these things going on. You might find it relatable. You're trying to run some sort of web app that someone else has made, and then you are getting these errors. Postgres doesn't work. Someone tracked their runs on Excel, which I have seen. I've actually seen, and that's fine, right? I'm not saying doing that is not good, because I've done that as well. I've tracked stuff in Excel, but it's just hard to let someone else take over this code. So this brings us to our next point. In the real world, machine learning code by itself is pretty useless. And this is a pretty well-known graph from a paper called Hidden Technical Debt in Machine Learning Systems. So note that in the center, there's this black box, no pun intended, that represents machine learning code. Everything else that's required to get that raw data to the model, set up reporting after, serve the model outputs into a dashboard or a fraud detection tool or on-demand integration, requires all of the infrastructure blocks around it, right? All these blocks around this black box. So basically, machine learning code and models by themselves are pretty useless. To build all of that surrounding infrastructure, usually there's a team, right? If the product has any sort of user base and has some sort of traction. I'm not talking about my student side project, because yeah, maybe that wouldn't require a team. So I'm going to go through this quote from a blog post by Eugene Yan, which I think illustrates the communication friction in a team. So first of all, maybe a data engineer and data scientist need to communicate. And then after the model's done, data scientist and machine learning engineer discuss how to deploy it. And then when there's any issue, all of those people need to be in the room, and probably a PM as well. So 4 people. And to build the infrastructure to make machine learning useful in the first place, remember all of those blocks, it's too big of a problem to tackle alone. But this can lead to a frustrated team because of all of that friction where, oh, I took someone's code. Okay, I don't know what to do with it. I need to ask them a bunch of questions to get it to run in the first place. So with that context, I'll talk about having an end-to-end machine learning platform and how that helps reduce that communication friction by helping each data science role focus more on what they do best. So the end-to-end machine learning lifecycle, right, as I mentioned, requires a lot of pieces, from data ingestion, feature extraction, model building, serving, etc. A lot of teamwork here. So Kubeflow is a machine learning platform that's capable of connecting and orchestrating all of this end to end. And I just want to bring this as an example. I want to emphasize that there are other types of means to an end. And I believe that these principles that I'll mention can be achievable, Kubeflow or not. But I will use Kubeflow as a primary example here. So using Kubeflow pipelines, which is one of the bits in the Kubeflow toolkit, we can create modular and reusable machine learning components. So it provides an optional but really useful graphical interface, as in the screenshot. In this example of an XGBoost model, it's written as a DAG, which stands for Directed Acyclic Graph, meaning that the data flows one way so that the process is repeatable and it's deterministic. So it will not form a closed loop. And this is all constructed in a way that if I'm on Kubeflow and I run this DAG, it'll run the same for everyone else. If I create a Python script for model training, someone else can reuse that in their own ML DAG workflow. If I want to have a training step twice in the same DAG for some reason, or have some sort of logic going on, I don't need to rewrite things or have some really ugly copy-pasted nested loops. I can reuse the components in the DAG. So let's explain why that is so reusable and portable, right? So imagine running someone else's environments and they just work. You're not installing random things on the Python local global environment, right? This And just being able to run someone else's work is so valuable and saves so much time in a data science team, right? This includes not just data scientists, but data engineers or data platform engineers or machine learning engineers or web developers. Like, I'm not trying to define all of those roles specifically, but just anyone doing anything related to data scientists. So this is doable because it is all run on Docker, which I bet the majority of you are familiar with and are using, or containered if we're thinking a bit far into the future when some changes to Docker will be made. But let's not get into that here. Kubeflow pipelines is Dockerized down to the component level, which is one of the little blocks you see on the Kubeflow UI, which could be like a train step or processing step, which is like those little blocks on the screenshot. So at every step, the metadata is also persisted, which can be conveniently seen on the UI or persisted to your database of choice. So there's no more making little notes about what type of inputs or pre-processing you made into your model with an ad hoc script, only for your coworker to use the wrong pickle file when they're running it. Kubeflow tracks exactly what's going in and what's going out. Now to dive a bit more into the MLOps details, I've heard of machine learning products where the data scientists build something and then on the website they translate it to Java after the data scientist throws the code over the wall. And this is a true story. Like, I'm sure this happens more often than we'd like to think. And with Kubeflow, as I mentioned, the models are in containers and all the steps are in containers. So if your production stack uses Docker, the chances are you don't need that painful, like literal code translation. And anything that runs in Docker can run on Kubeflow. So naturally, that includes Python and all of the machine learning packages and friends, TensorFlow, scikit-learn, XGBoost, and so on and so on. And all the tools are available too, like Jupyter Lab. And we happen to use Google Cloud Platform, but Kubeflow supports AWS, Azure, IBM, OpenShift, and so on. And let's say now you have your platform of choice. It's still a fact that if you were to build an end-to-end machine learning platform from scratch, it's too big of a challenge to tackle alone. I'm going to go a bit into Kubeflow and Kubernetes functionality and how that's helpful. You can run Kubeflow wherever Kubernetes runs, which is a very common and popular framework that a lot of modern tech stacks uses. And Kubeflow is able to be configured and scaled. So if your company needs a custom solution, it's very transparent. You can do follow the CI/CD practices. That is probably what your tech stack is using, possibly. And data science gets visibility into all of that capability for automating deployment or scaling and application management. So this reduces a lot of the redundant and siloed work. And I've talked about Kubeflow specifically, but I do want to emphasize that if you use it, you're not totally locked in because it's designed as a suite of tools that can be mixed and matched. On their recent developer survey, a lot of respondents used just a few tools in the entire toolkit, not necessarily all of them, right? So you could want to do hyperparameter tuning with Katib, which is a Kubeflow tool, but you could also use a simpler Python solution and mix and match. And the second point is I haven't really touched on every single thing in an end-to-end machine learning project. Like, there are other pieces. I haven't even mentioned Clearbanc's like web stack or something like that. So it's kind of like you can keep zooming out. And depends on what you want to do here, you can pick and choose the correct or suitable framework from Kubeflow or other type of framework. So I know we're reaching time, so I will wrap up this section. There are other things that are commonly used in these end-to-end machine learning pipelines and platforms. You could mix and match MLflow, which is good for doing tracking of like experiments. You can do Airflow, which is a popular tool, which also uses the DAG logic, the directed acyclic graph that Kubeflow pipeline does, or Luigi, which is another kind of workflow tool. And I encourage people to check out Kubeflow or other types of platforms and tools that can help achieve that goal of reducing the friction and getting that end-to-end visibility. And Kubeflow does have a friendly network. I've made a few commits to the source code and documentation. I'm just saying this just to illustrate how chill and welcoming they are. So you can just join their GitHub and hop on their Slack. So now I'll just wrap up this entire section by saying how having more of an end-to-end visibility in production especially can help reduce the development time and the completion time of production projects. So like I mentioned, having that visibility has a goal, right? You're not just doing it just because. You want to reduce this unreproducible, repetitive, and wasteful translation work between data science functions. And data scientists can continue to work with what they are familiar with, which is likely Python. But if they want to tinker with the workings of Kubernetes or the pipeline logic, they can. They don't need to jump through hoops and hoops and hoops of teams to get that visibility. And as a result, between all types of data science roles, there is less friction, which are what are the common challenges that I mentioned before. But people can focus on what they do best, right? Instead of working a lot on that translation glue work. And just to give a personal example from what I enjoy from I guess more of a data scientist perspective, what I enjoy about this visibility is, let's say I can see details of Kubernetes clusters, their deployment and resourcing without needing to bug someone from another team and that person to bug someone from another team. Using the Kubernetes command line tool, kubectl or kubectl, or the GCP UI, I can pretty much see exactly what's going on. And of course, like depending on the next point, which is there's a lot of rule-based access control. So this is a common term, which is kind of like you separate namespaces or have service accounts do automated jobs so that people who shouldn't be seeing some things don't see it. Depending on your permissions, there is pretty good design in Kubeflow in particular, but I'm sure in other tools too, that I really appreciated, because then people can get these roles as they need and as they want to. And this increases the kind of security that I myself might not have thought of, but it's pretty well designed that I've been able to use it and feel just like more at peace. And if it sounds like from a data scientist, I'm being too curious or tinkering too much with these types of things, I do want to emphasize that the goal is helping everyone focus on what they're best at, and you're not, I'm not mysteriously shifting some environment somewhere and then let's say an ML engineer or platform engineer takes that and they don't know what to do with it. And we just have back and forths and hot potatoing. The goal is overall resulting in better efficiency, faster speed from model training to putting it into production. So from months to weeks or less, depending on what type of project it is, what kind of product it is. So I think this is, from a data science perspective, it's really, really useful. And yeah, instead of that frustrated data science team we saw earlier with a lot of friction to put machine learning into production, now we have more peaceful phases. And that was my experience as well, getting to work together better and have more visibility, release things faster. So I hope that you can do that too. Let's go. So that is the end of my talk today. I hope that was helpful for you to think about your own machine learning production and deployment, especially if you have a meaningful amount of users and you're looking to scale. So I'm open to chatting more about this topic or other data science stuff in general. And you can find me at these places, LinkedIn, Twitter, or my website. And thank you.
Thank you, Susan. We'll open up the floor for Q&A. If anyone has any questions, you could post it on chat, and I'll just kind of field some of the questions. I think we had one question earlier. It was from Japjit about what sort of game does your studio develop?
Japjit knows, because I know
Okay.
Japjit, but yeah. I'll just mention it. So It's kind of funny. I started game development when I was in university, and I've built some games. My first game was my first commercial game, which means that it's being sold, is about dogs fighting for social standing on an island. And I'm working on future games. But yeah, I know that this is like, it's probably lunchtime in Toronto, which is where some people are from. So, you know.
Very interesting. So we have a question from Mitchell. Did you find it challenging to explain the benefits of ML ops to the larger business?
Right. So I think from my perspective as a data scientist, it's really important to be able to tell that story and the benefits. And I think the business is really open to hearing about these types of things. But it's kind of our job to translate like a lot of the kind of nitty gritty into like value. Because so for example, I could be going in and being like, hey, kubectl, like describe pods and stuff. But no, I'm not going to do that. I'm going to have to be like, oh, we need to manage these resources because when there's a lot of users hitting our site, like this will be better and this will be more resilient. I think that is a big part of doing good work as a data scientist, which is translating and kind of providing that. So yeah, it's not smooth sailing all the time to explain the benefits, but I think if we talk about it in terms of, let's say, developer time, for example, that's like a huge way to quantify things, or kind of thinking about the time it goes from models to production, or thinking about the time where someone developed something and the code is rotting there and then they wasted like 3 weeks. That is really big impact. And I think that's a really good way to help speak and communicate to the kind of broader group.
Mm-hmm. So I guess a little bit more specific, I guess, how does Clearbanc see the benefits of ML, and how do they talk about, like, what are kind of the discussions around it internally? I guess maybe that's allowed to be disclosed, but
yeah. So I'll mention this on a high level. So I guess there are different ways to look at companies who do ML. And one way I kind of look at it is machine learning part of their kind of core thing? So in Clearbanc, fortunately, that for the people who sign up on our site to apply for funding, they all do go through the machine learning flow that is happening in the background for the decision making. And it's just when the machine learning is part of a core company product, it's like smoother sailing. I'm not saying this is always the case, but there are companies where that the machine learning is more of a supporting or kind of peripheral thing, and in which case your communication or the kind of benefits and the way you discuss them internally will differ a little bit. So when it's a core product, yes, you can talk about the benefits of ML internally, right, with more of a assumption that everyone's slightly more on board. And then when it's a type of product or company where machine learning is more of a supporting role, then you might need to adjust the way you communicate internally as well. So this is something I've seen from industry, from experience, from folks that I know. And I think this is useful to think about because some people are not kind of aware that they need to change their messaging a bit, depending on what the situation is.
Mm-hmm. And I guess in a small team setting, are you used to seeing engineers doing data science tasks, or the other way around where data scientists do engineering tasks? Is there a...
Yeah, I think in a smaller team, the more likely it is that there's some sort of overlap. So I would say, like, let's say you have well-defined roles. So like it would be that kind of situation where you have like someone does their work, it's like a very strict line, and then someone else does the other piece, and then someone else does the other piece. I find that in smaller teams, it's more like there's like definitely a bit of overlap in the middle, which there's definitely a good balance here, right? Like you don't want everyone to be doing exactly the same thing. So everyone would be like very end-to-end data scientist, which is fine in some settings, not, which is like, it depends on how much you're scaling. And I think I'm used to seeing some overlap. Everyone has like probably like, I don't know like if T-shaped is the right term here because it really also depends on the company. But like in smaller teams, what I've seen is like, let's say someone is very good at something and they're like decently exposed to other things as well. They're not completely clueless about, let's say, data engineering. They might know less about it, but they can kind of speak and understand like when some other things related to like data platform engineering is brought up.
And I guess kind of talking about the development cycle, what are your thoughts on the full life cycle machine learning, which is a trending term of the ability of a smaller team to fully manage? Does it improve? I mean, is it improving, or if so, are the improvements meaningful?
I see. Yeah, and for smaller teams, okay, I'll mention two examples. So like one is, let's say you have a large company with like a huge, massive tech team that is literally the size of a small company. So in this case, they could probably afford to build their own end-to-end platform all by themselves because they'll have like 5 people on some component and 5 people on another component. They could do that and then they could later open source it, right? So I guess if we're ignoring companies like that because you can just throw a bunch of bodies and a bunch of money at it, let's say it's like more of a mid-sized company, I think it's important for learning and kind of applying this full life cycle machine learning just because of the visibility that it provides. And because in smaller companies, usually the kind of, so for example, in my case, I have visibility into how the web stack in Clearbanc operates, where I probably wouldn't in a much, much larger company because there would be like a couple teams degrees away. So I think this is meaningful because it helps me understand like what the users want better, right? Like I can actually see some sort of sign up flow and like the kind of data that is being requested by the kind of front end. And I think this is important because when I'm designing things, I can keep that more in mind and I can actually design with that in mind, or I can make model inputs with that in mind, or having more visibility on the other side, which is like model inputs, what's available helps me build products that are just like faster, like from beginning to end. And so I think that's why full lifecycle machine learning is kind of gaining traction because of that kind of issue with people just going in circles and having their code just like dead and not in production. And it is challenging to manage, I have to say, right? Like you have to mix and match pieces. You have parts of the stack that were there, and then therefore new parts probably need to play nicely with them and such. It's not smooth. It's not like that. Otherwise, every company would have all their end-to-end machine learning like in a week. But I think the improvement is that you can have better products and better collaboration.
Mm-hmm. I see. And I guess our last question is, what do you think about NB Dev?
So actually, I'm not really familiar with it. I haven't used it. I think it's some sort of Jupyter notebook stack. I have actually no idea. So unfortunately, I can't really comment on that.
Okay, well, I think that should be all. Yep, I think that should be all the questions. Thank you so much for the amazing talk, Susan. I think echo the sentiment of everyone in chat and here in TMLS that this was such an insightful talk, and really appreciate you coming back to present with here.
Awesome. Thank you so much, everyone.
Thank you.